In this section, we're going to solve a variety of types of equations. This first polynomial equation has a t to the third in it. We try to factor out a GCF from all four terms, but we notice there isn't any. But you'll notice that 98 is double the 49, as 8 is double the 4. And that clues us into the fact that perhaps we can use the grouping method to factor this equation. I've split the equation here into two different parts, and I'm going to begin with the first two terms, factoring out a 49t squared. When we factor that out, we're left with 2t minus 1. In the second half of the problem, the third and fourth term, we can factor out a negative 4 and have 2t minus 1 again equal to 0. We then factor the common factor of 2t minus 1 out in front, leaving 2t minus 1 times 49t squared minus 4 equal to 0. That second factor there is the difference of two squares, so we can factor further 2t minus 1 times 7t plus 2 times 7t minus 2 equals 0. We now can use the zero product property to see that t can equal 1/2, negative 2/7, or positive 2/7. And those three values go in our solution set. This next equation is a rational equation, and we begin by factoring this third denominator, and we notice that it is the product of the other two denominators. So we want to clear the fractions by multiplying through on each side by the least common denominator, which turns out to be this third denominator, c minus 5 times c plus 1. Distributing that through to the first term, the c minus 5's will cancel, leaving 4c times c plus 1 minus 1 times c minus 5 equals 3c squared plus 3, because nothing will cancel on the right-hand side. Now we're going to do some distribution on the left-hand side. That will give us 4c squared plus 4c minus c plus 5 equals 3c squared plus 3. It's now time to combine like terms on the left. We will have 4c squared plus 3c plus 5 equals 3c squared plus 3. This is a quadratic equation that we want to have set equal to 0, so we're going to need to bring the terms from the right over to the left. To that end, we will subtract 3c squared on each side and 3 on each side. And this will leave us with c squared plus 3c plus 2 is equal to 0. This is conveniently factorable, and we find it factors into c plus 2 times c plus 1, and therefore c equals negative 2 or negative 1 appears to be the solution set. But if you take that negative 1 and substitute it into the original problem, you will notice that it produces a 0 in the denominator. And so our solution set consists only of the value negative 2.